Yeah, hello everybody from Germany. This is Matthias Martus speaking. I'm Managing Director of infraTest Prüftechnik in Germany, and I'm happy that we can share a couple of ideas and share a couple of new technologies which we invented in the last 5 or 6 years here at infraTest. This is our headquarter building, which you can see here on the pictures. We have a couple of different locations in Germany. So the headquarter, as you can see, in a town called Brackenheim, is close to the Stuttgart area. We have another facility not far away east of here where we do all our metal works, and all our workshop facilities are located in Obersulm, which is half an hour away from here. We have our DAKKS Calibration Center, which is located in central Germany, a town called Schalkau. We have the Geomation company where we do our geological triaxle and geological testing equipment. The Geomation company is located close to Dresden in eastern Germany. And finally, we have a service and sales office in Castrop-Rauxel, which is northwest, where we have service departments and sales department. Yeah, this is what we have in Germany. Internationally, we founded quite, in the meantime, the last 5 years, quite a lot of service and sales companies. We started in Russia with infraTest Russia, then we went to the USA. We went to India. Currently, we are moving to South America. One of our longest partners is the IT infraTest Hong Kong and the infraTest in China. And then also very nice companies, infraTest Adria, infraTest Scandinavia, and infraTest Australia. We were founded in 1991, means we are heading our 13th anniversary, which is coming next year. So we have 13 years of experience in producing and manufacturing testing equipment. In the meantime, in all our factories, we produce and design and manufacture some 720 different testing devices. The range is mostly binder testing, and asphalt testing, geological testing, as I said, and concrete and cement. Worldwide, we have 140 employees at current, and very interesting figure for us that we have an export ratio of around 75%, which is for a small company like we are a huge number, and we are happy that we have such a good logistic systems behind us, so we can really be in this, or work with this high export ratio. Totally items of our product range at this moment is around 2,200 different products. Yeah, we are a very innovative company. From this 140 people, we have 20 design engineers who are responsible for the mechanical, for the electronics, and for the software design. Everything is designed in-house. Everything is designed and manufactured in Germany. So when we calculate it, we have around 40% of our workforce is only doing research and development. That means we are, of course, a leader in innovation. We are a leader in precision and accuracy. And of course, we are the most copied company in our relevant market. When it comes to accuracy and precision of the design, or in the design of testing equipment, there is always a long way until you finally get to a new design. Everything we do starts with an FAM 3D calculation, where we can calculate the stress and the performance of the machine itself, because we have to know exactly what the performance and the stress of the machine is before we start discussing about the performance of the asphalt or the binders. Give you an example for that. What you can see here is simulation of deformation during an indirect tensile test. You see here different colors, which means these are different stress areas and different deformation areas on calibration on a calibration sample. We always start with design like that in order to know how the testing machine is working at the end. Without this, we cannot see if all the forces and strength we have to deal with inside the machine are not influencing the result of what we want to test. Yeah, a machine must always do the same. So we define it as imprecise, accurate, precise, inaccurate, imprecise, inaccurate. And you see, I like this picture. And at the end, you see, we think we find us on the right bottom side. So machines must always be precise and accurate in any times, in any circumstances. We must have reliable results. Yeah, now I want to show you some inventions we did over the years. As I said, we were founded in 1991. And everything started with the innovation of the so-called Asphalt Analyzer. We patented it in 1998. It was the first extraction machine, closed cycle extraction machine, where we could provide a safe handling of solvents inside the circle with a closed loop system. Before that, everybody was making, including us, everybody was making some sort of automatic extractor where you openly could, or you had to openly handle the solvents which are dangerous. And so we invented this Asphalt Analyzer where we put everything inside a machine and inside a closed chamber. It starts with the filling of a so-called washing drum. Then you go to the centrifuge, and as you can see here in the circle, then the recovery is coming. And at the end, the binder is automatically recovered with the evaporator. Here we started with a machine like that. What you see here is the first innovation, the Asphalt Analyzer in the year 2005. With this machine, we had significant success in Germany. And from this type, we sold around 600 machines in Germany to mixing plants, universities, and different research institutes. Innovation never stops. This is the model from 2010. We included there a complete software package, including a computer screen, a touch screen. With this machine, we already could start with, we had remote access and could make service and technician works or preparing technician works, which is maybe necessary in case of a malfunction we could provide online. 2015, not only the machine improved, but also the system improved in ways of that asphalt is getting more and more complicated. This machine has a collector, which you can see on in the middle side of crumbed rubber, which we want to get measured inside the machine, which we could make with this innovation here. Yeah, and then the next step in 2017, we started to make machines for high boiling solvents or dangerous solvents. This one was designed for the extraction of toluene, which is highly explosive and inflammable solvent. So again, from size of machine, this has to be even more close than normal machines, which leads to this innovation here. Yeah, then we came to the year 2020 in Germany. It started that we had to apply for special permission to use the trichloroethylene. So the industry turned into tetrachlor. Tetrachlor has different behavior when we have to recover it from out of the binder because it has a much higher boiling point. And we designed this machine especially for the extraction of tetrachlor. 1 year later, we came out with something we are really proud of. We had then a modular system. All these modules you can see can be fixed differently together. On the left side, you see the normal washing chamber with the centrifuge. On the middle side, we have a recovery which can be additionally adjusted with a washing chamber, a second washing chamber for complicated asphalt materials. Then the first on the right is the evaporation, and the second on the right is a washing machine for the glassware. And all these 4 units can communicate with each other. That means that you just fill the washing drum, and at the end, after 1 hour, 1 hour 20, you can collect the binder directly from the glass flask, which you see in the middle of the picture. For us, this was a really great innovation. A lot of work behind this, as you can imagine. A lot of detailed work with the new software technology we never used before. We can, as you can see, as an example here, we can adjust every valve, every single step in the machine. We can adjust, not only for service reasons, but which is more important, to adjust it to different asphalt materials, including recycled asphalt, which is getting, for the purpose of extraction, of more and more importance. Here you see the automatic evaporator system, which is also controlled by the central control unit. Yeah, we have a 2-bath system. The evaporator can move from the cool side, which is according to European norm around 90 degrees, to the hot side, which is around 160 degrees. So everything is going completely automatic. Finally, which is of course, as we are handling dangerous materials, dangerous solvents inside the machine, this is the solvent management. Which you can see on the left side is the fresh solvent is going out into the machine. On the right side, we have the recycling container where everything is stored. So with this type of machine, the lab staff has no contact at all with any solvent they use inside the machine at all. Yeah, this is this year, so it's 2021. So what can you expect in 2023? We are already working on extractions with a handling system, with a handling robot. Here, this robot can feed the machine with prepared washing drums and prepared centrifuge caps. And at the end of the extraction, the robot is communicating directly with the machine, is removing the extracted binder and the extracted aggregates, and is filling it with new aggregate or with new asphalt. So we can extract during the night around 5 or 6 samples. That means when you come in the morning, you can collect the results and can go working with it. Next step after this, we want to design, we call it kitchen aisle solution that you can work around. And the kitchen aisle solution will definitely include a DSR. That means that we go automatically from the evaporator. We fill the silicone forms of the Kinexus at this point. And so we can start with the extraction. We go to the evaporator, and at the end, we collect the DSR results. Of course, every machine, as we have very advanced computer technology installed, every machine can directly communicate with some, however, designed cloud system, and we can send all the collected data to wherever we like, wherever you like, of course. Yeah, that is a whole, let's say, innovation process. When we talk about extraction, you see, every year we have something new, some new invention when it comes to this extraction. Still, the robot is surely not the end. We will see where the journey is going. We always have to adapt the machine to the needs, to the change of the asphalt, and to the change of the regulations, national standards, and whatever we have. So I think this will never be boring. There will always be a new task and a new idea and a new program to perform. Yeah. Second thing is Or second example, I only can give you some examples. As you can imagine, I said we have around 700 different machines we produce, so we can always only talk about examples. What we are very proud of is our modular performance testing systems. You know, performance testing is getting more and more importance worldwide. We started with the design of testing machines some 14 or 15 years ago. We came from very small machines because we thought these small machines are fitting better in the normal labs. So we started with a smaller machine. This one was designed for a maximum force of 10 kilonewton and a maximum frequency of 10 hertz. Of course, then asphalt standards and applications get more and more complicated. So at the end, you see this is a machine which is 10 times bigger than the first machine we designed. So with this machine, we are able to perform all standards currently existing worldwide. Yeah, again, we see that the handling of the sample inside the machine is a source of a problem, because we are losing preciseness and accuracy because of the manual feeding of the machine. And what we did is we used using a similar handling system we had before for the Asphalt Analyzer. This handling robot can also feed the performance testing machine with a very high preciseness, or a higher preciseness than a human hand can ever do it. Yeah, in the same chamber, also this was an innovation from infraTest that we firstly had the first three-place system for the TSRST. You see here, it's a huge steel frame construction, which is inside. What you see here has a total weight of 290 kilograms. Which means when we talk about, you remember maybe my first slides with the 3D dimension calculation, this is what comes out when we calculate it. And you see we need a lot of steel around the testing sample in order to have the real preciseness we want to have. Yeah, something which is not very common around Europe, but in Germany we have a couple of institutes, including the BAST, the German authority, working with the so-called REVIS system, where we can have the rheological properties or the creep modulus properties for, here it's, you see it looks like a dog bone, where we can test the properties of binder and filler. Yeah, very interesting innovation we had some 4 or 5 years ago with our normal mixing systems. We included a workability measurement. That means we can have a very accurate signal about mixing energy we put into the mix itself. We think this is a very, very important thing, because during the mixing process, so let's say in starting with the first test you do in a laboratory, you can already destroy your aggregate, and then you can come to completely different results. So we think it is very important to measure the mixing energy during the mixing process. I just made you a short picture where you can see the Newton meters against time and temperature. The gyro, one of our latest inventions. We had the feeling that the market needs a very, very strong construction. That's what we did. This is in terms of weight and the strongness. This is a monster. In Germany, we never had it. It was never important to have a machine like that. But now with the new problems we have with low temperature asphalt, we think that this gyro could be a good solution for testing new additives and new systems. This is what we are working right now. You know, the sector compactor, which is a standard testing method around Europe for for a while, I think more than 10 years in the meantime. What we do right now is that we automatically measure the void content under the roller, and we measure it with every crossing of the roller inside the sample. And we want to see, or we want to feed the machine, the intelligence of the machine with the signals of the void content, so that the machine can itself prepare the next steps and the next reactions. Yeah, we not only have innovations in terms of advanced machines, but we also have innovation in terms of ergonomics. Here we have included in this machine, which is a simple and standard wheel tracking or Hamburg wheel tracking machine, we included some lifting devices in order to save the bones of the lap stuff, because this arm is normally very heavy to handle. infraTest pavement scuffing device, one of our newest devices we have. You see a turning table is under a wheel with a certain pressure, and we measure the breakout of the in the asphalt during the process of turning. Something which might be interesting is our so-called sample scanner. You see here a normal Marshall sample. We just put it out of a normal Marshall frame, put it into one of our scanners, and measure the texture and the complete void content on the surface of the sample. It may be interesting for future works. Then we have our newest, I can say, innovation, the infraTest sensor technology. We started some 2 or 3 years ago with the design of temperature sensors or temperature scanners, which we put into the asphalt during the paving process. You see that we put them in different layers, also in surface, binder, and base layers. They all give different temperature signals, and with that we are able to measure the complete temperature range over whatever we want to have. I show you in the next slide. We can all measure them independently. We can change the measurement interval. All these sensors have an internal data storage or data storage. They're all able to get the wireless programming and configuration. Of course, as they are in the asphalt, they have a certain battery, and at this point, the battery lasts, depending on the measurement interval, around 2 to 3 years. The readout can be done with a manual device or with an automation device. Here we see on this slide, we see short-term measurement. We see the temperature is going from, it's getting closer to the environmental temperature, and at hour 23, which we can here see, we get the second layer on it, and then the temperature was rising again and going down again. Yeah. This is interesting because we here at this point we're around 3 months. What you see here is the air temperature min max, which is coming from weather station, and we have the core temperature, which is connected to these signals. Yeah, acceleration sensors is a very important and very interesting thing. Whenever something is happening on the road, we have vibrations, and vibrations go to acceleration, and accelerations can be measured. Of course, we have a huge data which we have to collect, so this one has to be connected with a central station. So we have a certain control box which could be or is connected with the cloud, and the vibration sensors or the acceleration sensors give their signal directly to the box and then to the cloud. We can measure, of course, X load, X configuration, traffic density, vehicle type, and of course, with long-term studies, we also can have information about the life cycle and can make a life cycle forecast. More sensors, of course, vibration sensors. We have strain sensors. So there's a whole range of different sensors we can provide. Also, this is not a sensor. This is a very standardized RFID technology, but we can put into asphalt or into concrete or into whatever we can put in RFID sample, which is also collecting data and giving this data directly to our infraTest app, which we are very proud of, which we designed this year. This one is just under our in different laboratories under suspicion. They are under test. And see if the app is working as we want to work it. Yeah, finally, a very funny thing, but not it's not so bad. The idea, as we found that in laboratories you have different lives and different different testing equipment, and not all of these testing equipment have an interface which can communicate with the central lab software. Some labs have. So we designed something we called ASTA. It's asphalt data. So whenever you shout ASTA, you can call ASTA. I don't know if she's a her or a he. I don't know. We have to find out. And this data you transfer with your voice as a human interface. You can transfer it directly to your lab software. Yeah, you see. All this is coming not from something. This is all is coming from these people who are more or less superheroes, as we have different people working in the project from Hulk to Superman. We are quite convinced that what we do is not so bad, I guess. Yeah, okay, now I'm here. I only have 3 minutes to talk about the questions. All questions I cannot answer right now. I will give you an email and give you more information. First question come from Lotti about how can we use the asphalt analyzer with more advanced bitumen additives and bio-based components. This is not a problem of the asphalt analyzer. It's mostly a problem of the used solvent. You have to choose carefully the solvent you use for different additives. There are a lot of different solvents we can use in the meantime. So depending on the type of bio-based components which you have. Yeah, most interesting markets around the world for automation is, of course, everywhere where you make huge amounts of extraction. So we have some laboratories, they make with 3 machines, they make around 25 to 28 extractions per day, and for them it's mostly interesting. So far, I have some ideas for some customers in the USA where you do have such huge laboratories. Is the data generated report from the workability device, and is it according to 12697 part 50? Yes, it's according to 12697 part 50, and you get all the reports you can get, which we create in the machine. You can print out or you can store for further studies. And the temperature sensors or the sensors itself. I cannot answer in 1 minute, but I would be happy to come into a deeper discussion. I will be online all day, so we can talk about this later. I think the sensor thing is really, really interesting, and I hope to have as much discussions about this as possible. Okay, so that's it. I think my 3 minutes are over. And I hope you join some more presentations we have online here. I think the next one is right now with our sector compactor. Stefan Dreker is doing it. I wish you a good Congress, and if it's finished, as much beer as you can and as much wine as you can. And I still hope that the European we win the European Football Championship. If not, I don't know. Thank you so much.